Namaste and welcome back everyone. Now that we have explored so many things in the distance time graph and displacement time graph, this is our right time to start the velocity time graph. This one is the most interesting and I am going to tell you why in the next video. So in this we are going to focus the velocity time graph, or in another word speed time graph. So in the velocity time graph, what we actually can do, when you draw a line which is called as slope in the velocity time graph, either increasing or decreasing, it doesn't matter, it's just about the number, increasing graph or decreasing graph. So in the increasing graph, when you make that, there are two possibilities. Velocity in time, when you draw a slope in velocity in time, it gives you the rate of change of velocity. It could go positive or negative. That term is called as acceleration or retardation respectively. Now let's think that is there a possibility of the area graph in this one? Let's try this one. So let's draw a area, a square. Now velocity multiplied time, v multiplied t, here it makes sense, and that will going to give us the distance or the displacement. So this will going to make sense the area graph. So velocity time graph is the graph in which both the things are making the sense. So in the next one we are going to explore the acceleration time graph, but before that let's explore one more interesting case. That is the question for you: what will happen if the velocity time graph is having a parallel line? If we draw a parallel line parallel to the time axis and the velocity, is that means it is at rest or motion? Remember, the course is all about the physics in motion. So take care, ponder upon this. God bless and namaste.